Imagine the universe as a grand cosmic symphony where stars, planets, and moons come together in perfect harmony. Each celestial body plays its own unique part in this intricate composition. Yet, among this beautiful and seemingly synchronized orchestra lies a region that has puzzled astronomers for generations. This is the mysterious realm of exoplanets, worlds that orbit stars beyond our own solar system, nestled deep within the vast stretches of the Milky Way. These are not just distant planets. They are entire worlds, each holding its own secrets. Astonishingly, some of these planets bear a striking resemblance to Earth. Among them is one particularly intriguing candidate, an exoplanet so hauntingly similar to our home that it has earned the title of Earth's possible celestial twin, Proxima b. This world exists just 4.2 light-years away, a mere stone's throw in cosmic terms. As we peer deeper into the night sky, the James Webb Space Telescope is changing the game entirely. It's not just helping us find these far-off worlds, but giving us tools to truly understand them. Let your imagination travel across the immense, galactic terrain of the Milky Way, a region that may harbor more than a quadrillion exoplanets. That's a 1 followed by 15 zeros. To visualize this, if each exoplanet were the size of a grain of sand, we wouldn't just fill the Grand Canyon. We'd have enough to build an entirely new canyon, a Grand Canyon 2.0, stretching 4 miles long. Even more astonishing is the fact that approximately 20% of these planets are considered Earth-like in structure and composition. That's a 1 in 5 chance of discovering a true planetary twin. But planets aren't the only celestial objects worth attention. There could be another quadrillion moons out there, rocky companions dancing around their parent planets, not unlike our own moon. For anyone holding out hope that we may one day find another body in space capable of sustaining life, the universe is offering an abundance of possibilities. Now that we've painted the picture of this vast and diverse cosmos, let's focus on the scientific marvel helping us unravel its mysteries, the James Webb Space Telescope. This isn't just a telescope. It's a precision instrument unlike anything before. Think of it as a cosmic detective, equipped with tools so advanced they make even the most powerful smartphone cameras look primitive. Its massive 6.5-meter primary mirror is 2.7 times larger than the one on the Hubble Space Telescope. With that kind of power, it can pick up the faintest flickers of light from stars billions of light-years away and examine the planets orbiting them in detail. What makes this telescope truly groundbreaking is its ability to do more than just observe. It's equipped with state-of-the-art infrared sensors and spectrographs that can analyze light in ways that reveal a planet's atmosphere, composition, density, and even its mass. It can detect whether a planet has water, organic molecules, or oxygen, all key ingredients for life. In that sense, it's more than just an observer. It's an analytical powerhouse, able to do in space what entire labs do on Earth. But let's bring our focus back to Proxima b. Discovered in 2016, this planet has fascinated astronomers and astrobiologists with its potential. It's incredibly close in astronomical terms, just over 4 light-years away. To put that in perspective, if you could travel at the speed of light, you'd get there in just over 4 years, the same span as a US presidential term or the time it takes for a beloved TV series to fade from memory. In a universe that stretches more than 93 billion light-years across, finding a potentially habitable world so nearby is nothing short of a miracle. It's like finding a diamond buried within a mountain of coal, a diamond that might hold answers about life beyond Earth. But it's not just its closeness that has scientists excited. Proxima b appears to sit within the habitable zone of its parent star, a region where temperatures may be just right for liquid water to exist. Imagine vast lakes, flowing rivers, or even deep oceans similar to Earth's. Yet before we start dreaming of vacations on this alien paradise, there are some unusual details to consider. For instance, a single day on Proxima b lasts about 11 Earth days. Sunrises and sunsets unfold slowly, creating long, golden hours that photographers would envy. But these extended light and dark periods could greatly affect the planet's climate and any potential life forms. What would life look like under such strange conditions? Would humans, if ever able to travel there, need to adjust their sleeping and eating patterns drastically? Would a single day require us to eat several times or change our biological clocks entirely? Everything we take for granted about daily life on Earth might be turned upside down. It's a paradox, familiar, yet utterly foreign, a challenge to our very definition of what makes a planet habitable. So how do we learn so much about a place we've never visited? That's where the James Webb Space Telescope becomes indispensable. It acts like a space-based Swiss Army knife, not just observing, but dissecting the universe with scientific precision. With its sophisticated spectrographs, it can analyze the light reflected from distant planets. Each chemical element or compound in an atmosphere has a unique signature, absorbing or emitting light at specific wavelengths. By studying those signatures, scientists can perform a kind of remote biopsy of alien worlds. Through this technique, we can identify key life-supporting ingredients: water, carbon-based molecules, even oxygen. This is more than just astronomy. It's forensic science on a galactic scale. The James Webb isn't just watching the universe, it's interrogating it, converting light and shadow into concrete data. It's transforming questions into measurable evidence, lifting the veil on mysteries that have lingered for millennia. But just when it seemed like we had reached the edge of discovery, something extraordinary happened. Scientists using the James Webb Telescope picked up a signal from the direction of Proxima b, an electromagnetic transmission so complex and unusual that it sparked a wave of excitement. Some called it a potential technosignature, possibly the footprint of an advanced civilization. The global scientific community held its breath. Was this the proof we've been waiting for? A sign that we're not alone? And then, just as suddenly as it appeared, the signal vanished. It did not repeat. It left behind no follow-up trace, only silence and a whirlwind of speculation. Was it a fluke, a cosmic misfire, or could it have been something intentional, a message sent across the stars? Whatever it was, it deepened the mystery of Proxima b, making it even more compelling to scientists and dreamers alike. Yet the story doesn't end there. Now researchers, including teams from institutions like Harvard, are pushing the boundaries of what's possible. They're enhancing the James Webb Telescope's abilities further, using it to search for artificial light sources in the darkened sides of exoplanets. The idea is breathtaking, to find city-like glow in distant worlds, as if entire civilizations were casting their lights across alien skies. Imagine the distant sparkle of urban centers, radiating like tiny pearls in the cosmic night, a silent signal that intelligent life might be out there, lighting up their world just as we do ours. The narrative of cosmic exploration is still unfolding. We have not yet turned the final page. In fact, the most astonishing chapters may be the ones still to come.